So in the question they have said that there is a hockey player. He is moving in the northward direction and suddenly turns towards west with the same speed to avoid opponent. What the opponent mean? Opponent is nothing but it is the player of the opposite team. Okay, he is the player of the opposite team. So when the hockey player he was actually moving the northward direction. So when he saw the opponent, he suddenly took a turn towards westward, so he suddenly took turn towards westward. Now they are asking us to find the force that acts on the player. So in order to understand that, let us understand this scenario over here. I have displayed here the front view of this scenario. So when this hockey player was moving towards northward direction, but due to the opponent, he suddenly took a turn towards westward. So let us analyze what the force was acting on this player. So when I analyze his foot, that is his shoes, then I can see that since the shoes which are taking a sudden turn, he exerts some amount of force on the ground. Okay, the shoes here, the person player exerts some amount of force on the ground. So this is what our reaction force. So this is what our action force. So according to Newton's third law, we know that every action has a reaction, and both forces are equal in magnitude and opposite in direction, and also the two forces which are action and reaction, the two forces are acting on the different bodies. So as this force, action force is acting on the ground, it is exerted by the shoes, then ground will also exert the same amount of force on the shoes. Okay, before the force was acted on the ground, now the ground will act some amount of force on the shoes, so now the force is acting on the shoes. So this force is called reaction force according to Newton's third law. So we know that since it is a reaction force, and we also know that this reaction force is generated in such a way that it is preventing the shoes from slipping, it is preventing the person from slipping. And we know that if any force which is generated such in such a way that to prevent the object to prevent the slipping of the object, then that force is generally called as frictional force. So indirectly the reaction force over here which was exerted by the ground on the shoes is actually indirectly it is a frictional force between the shoes and the ground. So we can say as, and also the person is taking a sudden turn as he is moving on the curvature, then there would be the action of centripetal force. And for your kind information, this frictional force between the ground and the shoes provides the centripetal force for turning. Okay. So overall, when I talk about this player, the what is the force acting on the player is only the reaction force, because the action force was not the force acting on the player, it was a force acting on the ground. When I talk about the player, what the force is acting on the player's shoes is only the frictional force. So here now they are asking us also the direction. So when coming to this scenario again, when he was taking sudden turn, then during that turn, he took sudden turn. Then during that time, when the frictional force between his shoes and the ground was directed towards the center of the curvature, that is towards this curvature, center of the curvature. So here from here we can see that this direction of the frictional force is actually lying between the south and west direction. That is nothing but this frictional force is directed towards the southwest direction. So our option C, the frictional force acting along the southwest direction is the force acting on the player is true.